any asset. By the way, what if I'm going to buy a share of stock? What am I buying? Why would you buy a share of stock in a company? Why would you buy, a share of General Motors? You want to share their profits. When do you get now that's going to be cash something, right? When do you get it? Oh, over time in the future. They're going to pay you dividends every year, maybe. Or you're going to get appreciation, increase in the value. And someday when you sell the stock, you're going to get the money, right? I've been investing since I was 30 years old. 29, I guess. I started teaching, started investing. I've been investing since I was 29, I'm now 64. And I haven't spent any of the money that I invested. I haven't spent that. I just keep putting it in. Right? Spend enough anyway. Right? So I just keep putting it in. So, if I was going to value that back then, what my retirement would be like, how much I need to have, what would I do? Discount it from what I need when I retire back to now. In my intermediate class, we just did that. We did a savings deal where they would put in 15% of their income at the beginning, right? And as their income grows over time, making assumptions about that, keep putting in 15% or whatever, and you build this future. Then we figured out how much they'd be worth when they retire, right? So many years from now. And then we figured out how much of an annuity they could buy for the rest of their life without running out of money, right? And we had to guess how long they were going to live, too. Anybody an actuary in here? Anybody going to be an actuary? Yeah, okay. You're going to be living in that world, right? You're predicting when people are going to die. Isn't that nice? Okay. But it's on average. By the way, if you buy an annuity and you live too long, right, you win. If you die soon after you buy an annuity, whoever sold you the annuity wins. That's how they work. Because they guarantee for the rest of their life they're going to pay you so much money, right? They don't really know how long you're going to last, right? But people on average, how long they're going to try to do it. Okay? So the insurance industry rules. Okay, anyway, so let's give this a shot. What things do you need to know to calculate the present value of something? What do I mean by present value? Oh, by the way, when somebody writes down a formula, what should you always do? Ask yourself, and if you can't answer the question, ask them, what? Well, I have blue today. Okay, what does present value mean? PVO, that's present value. I guess I should have said it the other way. PV and a little zero, what does that mean? Present value. Okay, now I don't want you to get too fancy with this. What do you think present value means? Just in plain English, what do you think it means?
Current amount to be received in the future.
Well, received in the future is the future value. Received now is what it's worth now. So you got to put the two bigs together. But that's too fancy. I want to know what the present value of something is. It might be what you're paying for it. What it is worth today. That's it. Okay? I bet I have $1. Probably all I have. Because I spent $60 on dog food and dog treats yesterday. Yeah. Why do people have dogs? Okay, anyway, yeah. She's so cute. Yeah. All around to pick up her crap. Go buy the food that creates the crap. This is stuff. Okay, anyway, and that's on paper. Okay, it's part of an accounting education. Anyway, what is the value of this dollar right now, seeing as it's right now? It's $1. What if I was going to receive it a year from now? It wouldn't be worth that much. If you believe it is worth maybe 90 cents, okay. If you believe it's worth that much, it's going to be worth more than that. We don't have that much inflation. Okay, but if you believe it's going to be worth as much later, you have a real problem, huh? I'll tell you what, I'll offer you a job. You don't have to do anything illegal or immoral, okay? You a job, $100,000 a year, and you do the work starting now. Would you take that job? 100,000. Sounds good, then. And it's even fun. It's fun, not illegal, not immoral. Want a job like that? 100,000. Greedy enough, right? Think of everything you buy with that 100,000. Oh, I forgot. You don't get the money for 50 years. Now do you want it? What's it worth? We can compute how much it's worth. You're getting paid very, very little. Very, very little. At a very high discount rate, that may be worth, I don't know, $5,000. Right? Because we invested $5,000 next year, the year after, the year after? Yes. By the way, do you care how risky it is as to whether or not you get it? Sure you do. Okay. So when we say PV0, it stands for present value times zero. And there are different notations for this. Don't worry about it. If you get in a class and they give you some other notation, somebody writes down something and you don't know what it is, what should you say? What is that? If you're in a business meeting and they write down something you don't know what it is, what should you say? What is that? Okay? Really a good idea. Really good idea. Okay? It annoys me when I read academic papers and they give you a whole bunch of formulas and a whole bunch of letters all over the place and they don't tell you what the letters mean. What are you doing? You might know what it means. I don't. Okay, so that's what cash is worth now. And another one is FV. What's that you suppose? Future value. That's where that's the other side of it, right? Present value is what it's worth now. Future value is what it would grow into in the future, right? Or you could know what you have in the future and then calculate what it's worth now. This is really good stuff, you guys. Really valuable. We do this for everything. And then we put a little N on that. What does N mean, guys? How many years, or really periods. It could be years, it could be months, it could be quarters of a year, it could be semi-annual. Got the idea? How many periods? That's all it is, right? Okay? So guess what? We use N again, number of periods, okay? So it's the same N, right? Small n, okay? And then there's one other piece, represents the risk. This is the time, when, right? This is what it's worth in the future. This is what it's worth now. There's one other piece. What is it? Rate. Okay, it's a little r or a little I. Okay? Little r means rate, little I means interest. We use them interchangeably. Okay, big deal. All right, so interest, what is that? It represents the risk of something. Okay? You know what? If we go borrow money, if we go to the bank and borrow money, are you independently wealthy? That's why you want to school? No, okay. Okay. Better not be independently wealthy. You have a challenge sitting in front of you. Otherwise, you have to decide what to do. Your parents ill or something. It's terrible. That's got money. But anyway, so if you and I were to go to the bank and borrow money this afternoon, please what your interest rate would be like compared to mine? Higher. Why? You don't have any money now, and I do. I don't need to borrow any money. I mean, I'm not rich or anything, but I don't need to really borrow the money. And they could look at my financial statement and say, yeah, sure, we'll loan you money. Because what's the risk of not getting paid? Very low. What's the risk with you? Also, in my age group, we tend to pay our bills. Or they already know we don't. They don't loan us money, right? We have credit history. You have a real big credit history. You borrowed a lot of money and repaid it. I'm married to a much younger woman than I am. Trust me, I borrowed money and repaid it and borrowed it yet. And no, anyway, we repay it real fast. But we have credit cards, and she puts money on the credit card, and we pay it off her, right? You know, and so we have wonderful credit. By the way, you guys, it's really fun. The first house I bought, I owed nobody any money, and I had a 25% down payment on the house. Been working as a CPA for a while, right? And the banker looked at me and he says, "We can't loan you any money." And I said, you know, it's $40,000 in those days, but it'd be like a $200,000 house now, right? You know, so it's $10,000. And so I said, you know, no, I don't have any debt, none. I have $10,000 and I'm making X dollars a year, which was pretty good money at the time, right? What do you mean you won't loan me the money? He says, you don't have a credit history. You need to go get some credit cards or go get a car loan or something and then make some payments for a while so that we can loan you some money. You don't exist. You're not going to get credit. So go out and run up a whole bunch of debt. You guys know I'm kidding, right? Don't do that. But you get a credit card and then use it and then pay it off every month at the end of the month. That'll build really good credit. They like to see that. It's silly, isn't it? By the way, they gave me the loan. They had a special meeting for me. I'm like 22 years old or something. They had a special meeting for me for the four bankers to convince them it'd be okay. Right? So anyway, yeah. I even got a letter from my boss or something. It's hilarious. Okay. So why would your interest rate be higher than mine? Let's say we went to the bank and we get a credit card, okay? You guys have credit cards? Good, you don't? Anybody have their own credit card? What kind of interest rate you got? You don't know? You never pay interest on it, I hope? You know what yours is? Yeah. 14%? Okay, so yours is 14%. My wife and I have credit cards, I don't know, that are 5% or something. How come? What's the difference? What's it composed of, you guys? You know what? Everybody gets a true return. You can think about this. This is not in the chapter, but it's in finance classes later when you do them. True return for everybody is probably 2 to 3%. Most theoreticians think, right? That's 2 to 3% of my 5%. It's 2 to 3% of your 14%, okay? Or 18, or whatever people have on their credit cards. They're horrendous ones, right? And then what we add to that is a risk premium, right? Well, that risk premium that's going to be added over here, it's for risk, right? Well, guess what? My risk premium is about 2 to 3%, right? 2% added to that, 2 to 3% maybe. What's yours? And it's not you personally, it's the group you're in, right? You're young, right? That's it, okay? What's the deal? You don't have a credit history yet. What's the deal? How much is hers? Take 2 to 3 away from 14, what do we have? 11 to 12%, and all of that is for risk. It gets worse. Included in this risk premium is expected inflation. We don't know what real inflation is going to be, but expected inflation, right, which right now is pretty low. We're only getting 1 to 2% a year inflation, right? And then you add to that expected risk. And the risk premium is the two of them put together. Well, you know what? I don't have much risk premium, really. The risk portion for me is probably 1%, huh? Well, yours is also 1 to 2 for expected inflation. Got the idea? What's your risk premium, guys? 10 to 11%, maybe? Wow. You know why that's so high? Because a whole bunch of people your age get credit cards, run up the bill on them, and don't pay. And they can't tell you from them. Except now you're a business major and you're sitting in here, and when you graduate, you won't have to pay that high of interest anymore. Unless you're really crazy and you run up the credit card, can't pay it, and declare bankruptcy, then you can pay that for the rest of your life. Don't do that, guys. Pay your bills. My son, I co-signed on a car loan for him, and he forgot to make the payment for 3 months. And he screwed up my credit. And I had to pay more interest. How angry do you think I got over that one? He paid me the interest differential. I went ahead and borrowed the money, and I gave him a bill. So what he cost me. And he worked to pay for it. Your parents, that mean? He wanted me to co-sign so he could have a car. And then he just forgot to make the payment. Don't do that. Okay, don't screw up your credit. Okay, anyway, these are the things we need to know, right? So this interest here is whatever it is. What is the riskiness of the project you're working on? So for UPS, what will they have for their interest rate? Probably pretty low, right? But when they invest in different investments, they might have higher or lower ones. That makes sense? Because some of the things they do are more risky, and some of the things they do are less risky. Okay? So yeah, it's how you value everything. Okay? No matter what decision you're going to make. When you're hiring people, you even do this. No kidding? Okay, so let's just do some simple calculations. Let's say we have a present value at time 0 right now of $100. I have $100. And I'd like to know what the future value is in number of periods from now. So I'm going to calculate this. Here's the deal. In every single one of these problems, you're going to have 3 of these things and not have one of them. And you're just going to calculate it. That's all it is. This is really simple once you figure out what's going on. Let's say n is 3 years. Let's make them years. And let's make the interest rate, to make our life simple, 10%. Can you tell me what the future value, 3 years from now, of $100 now, which is its present value, now is the present, right? Present value, compounded at 10% interest is going to be? Could you calculate that for me? The formula is what? Present value at time 0 times 1 plus the interest rate raised to the number of periods, that's a 1, plus the interest rate raised to the number of periods, is the future value of that number of periods from now. And as soon as you write something down like this, how many of you are just like, oh God, what are we doing? Most of you probably. Most people are. I say, oh geez, I have to do this. No, it's common sense, you guys. Look at this. If I have $100 now, that's the present value, and I invest it at
10% interest for 1 year, what will it be worth at the end of the year? How many of you want your $100 back if you invest it? Everybody. How many of you would like to earn the interest on the $100? Everybody. How many of you know how much interest there is at 10% on $100 for 1 year? What's the interest? $10. Wouldn't you have 100 plus the 10? You'd have 110. So look at this. Look what the formula does. 1 plus the interest rate. It's 1 plus 10%. Isn't that 1.10? I get my money back plus my 10%. Everybody agree? I get my money back plus the interest. Okay? So if I do it for 1 period, how much money do I have? 100 plus my $10 of interest. Does everybody agree? I have $110 at the end of 1 year. You know what? This is the present value at time 0. This is times 1 plus my interest rate for 1 period. The number of periods is only 1 then, right? And that's going to be a future value 1 period from now. But I want it 3 periods from now. So what do I need to do? I'm going to, oh, by the way, if you now had 110 in your investment, do you only want $10 interest the next year? No. You want interest on your interest, don't you? Everybody does, right? So we want $10 plus what? I want $10 on $100, but I have $10 of interest invested. What do I want for that? 10% of it. I want another dollar. Does everybody agree I want $11 now? If you have 110 invested, don't you want 11 the next year? Of course you do. Okay? This is common sense. This isn't math. Well, it is math, but math is common sense once you understand what you're doing. Would our mathematician agree with that? Just common sense, right? Big deal. It's just that common sense gets more involved, right? Business deal gets more involved. It's all what happens in our case. Okay, so what do we do with this? Well, let's get the future value 2 periods from now. Wouldn't you just take it times 1 plus the interest rate again? You guys agree with that? And like we said, there'd be $11, so I'd have my 110 plus 11, wouldn't I? So what is 110 times 1.1? It's $121. Does everybody agree with that? It's true, isn't it? Just adding the $11 to it. Okay, so that's 1.10 raised to the first. Okay, and or 1 plus the interest rate. I apologize. Keep the thing straight. If you can get this intuitively, you guys, this is really easy. Doesn't matter what the interest rate is, right, or what the number of periods is, or what the present value is, or what the future value is. It's always the same idea, okay? So what this would be is a future value 2 periods from now. And I suggested our periods were 3, so wouldn't we have to do it again? So what do? Just take this times 1.10. 1 time is what? Yeah, and 33.10. That's because on $121 invested at 10%, I'd want $12.10, right? Add 12.10 to the 121 and you get 133.10, don't you? Okay? So what this would be, of course, is the future value at the end of 3 periods. How many of you think that I wasted a whole bunch of time there? Imagine if I'd done it for 20 years. Oh, crying out loud. We don't do it that way, right? Very simple mathematically. What do you do here? We're going to take this and this and this and put them together, aren't we? And we will take what? The present value, there it is, right? Times 1 plus the interest rate raised to the number of periods equals the future value, that number of periods from now. So let's put this all together. It'd be 100. That's the present value at time 0. Everybody agree? Times 1 plus the interest rate, just like this formula says, raised to the number of periods. So it'd be 1.10, 1 plus that interest rate at 10%, raised to 3 periods. 1 time, 2 times, 3 times. I don't care if it's 1,000 times I could do this, right? Boy, that's a long deal. But 100, 120, 10 years monthly is 120. House loan, 30 years monthly is 360. Who cares? You plug it in the calculator. It's no big deal to do this, okay? It's the same idea. And so what do we have now? What does that grow to, you guys? A future value 3 periods from now, and guess what it's going to be? 133.10. Now, if you want to use the tables, what page are your tables on in your book? They're at the end of this book, right? Are they right at the end of the book? Yeah, the intermediate book, the right. At the end of the book, in one of the appendices. Wait, at the end of the book, I think, isn't it? Oh, it's at the end of the chapter? Oh, it's in here at the end of the chapter, and intermediate at the end of the book. Find the present value tables? What page is it on? You guys know what a present value table looks like? You read this chapter. Four six eight. 468. Really? No. Real present. No, here. There at the end of the book. You guys haven't done this yet, have you? I'm shocked. Holiday coming up. Maybe there's a new chapter. There are appendices. What page is that? A1. Appendix A1. That's it. There are appendices. Okay. On page A1, which immediately follows 688. Okay? First appendix. All right, there's the present value of $1. Okay? On the next table, on table A2, we have a future, A3 rather, we have a future value of $1. Everybody see that? And then we have an annuity table. Okay? Future value, present value, and annuity. Okay, so on page A2 there, look at the future value of $1. What interest rate did we use? 10%. How many periods did we have? 3. What's the factor there? 1.331. You can use these tables if you want. What is it? What they do to get that 1.331? They took 1 plus the interest rate and raised it the number of periods. They calculated it for you. By the way, you guys, we didn't used to have computers and calculators. These tables were really handy. There used to be books with tissue paper in them, basically, right? You could see through the paper. You had to put a piece of paper behind it so you could read it. And they were really thick, whole shelves of them in actuaries' offices, right? So you could look up every single interest rate possible almost, right? Like down to 0.16%, you know, and all kinds of different periods. What do we do now? Plug it in the calculator, now comes the answer. These tables are kind of nice though because you can see what happens, okay? So, by the way, at 10%, how much does a dollar grow to if it compounds for 3 years? How much will it be? $1 grows into what, you guys? $1.33. What if you leave it for 20 years? What does that $1 grow into at 10%? $1 becomes what, everybody? You can see it on the table. What does it say? $6.72. Each dollar you invest at 10%, if you leave it for 20 years, becomes $6.72. You have 7 times the money. Oh, what if you invest in the stock market and instead you earn 13%, which is earned on average, 12 to 13% over the last 30 to 40 years? $11.52. I heard this morning the S&P 500 has earned 18% in the last 7 years. 18% per year on average. What would 18% look like? We don't have that, but let's say 15, what is it? 1636, right? In 20 years, but I said 7, didn't I? So go 7. What's happened to your money if you invested at 15% over the last 7 years? You have 2.7 times as much wealth, right? Which is about what happens a month, or at least 2.5, probably down there at 2.5. And we're 2.5 times as much of what I already had invested 7 years ago, because the market's done so well. Yeah, get your money in the stock market, you guys. Anyway, what if you earn 20%? 3.6. Well, gee, why wouldn't you want to earn 20 instead of 12 then? You know what the difference between those interest rates is? Well, it's the only thing that's different, because expected inflation is the same, true return is the same, it's risk. You're taking riskier investments. Risk-return trade-offs. If you're willing to take more risk, you can get more return. Do you always get more return? No. What's risk mean? You might lose your money. There's always risk, guys. There's always risk. You could lose
your money. You work hard and you earn it, and then you invest it, you might lose it. Possible. Okay? But if you're careful with your investing, you probably won't. Okay, anyway, so that's easy, isn't it? So we could calculate that future value. Now let's do this. If I have that 133.10, everybody, and now let's say I gave you this one. I give you the 3 periods, I gave you the 133.10 future value, and I gave you the 10% interest rate. Could you calculate that present value if you didn't know it? What would be the process? How would you get there? If you knew the 133.10 over here, how would you get back to the 100? Instead of multiplying, what do? Divide. What if I divide 1.1 into 133.10? Where will I go? If I divide 1.1 into 133.10, where will I get back to? Yeah, that's the fast way to do it. But just intuitively, what would you do? If I had a future value out there, 3 periods from now of 133.10, what's the process of getting back to the present value at time 0? This is silly when I do this, isn't it? But it always is this. I don't care if the numbers get big or complex. It doesn't matter. It's always the same thing. What do? You divide it, don't you? By 1.10, and you will get back to a future value 2 periods from now, wouldn't you? The way we do it, though, is we take it times 1 over 1 plus the interest rate, okay? Does that make sense? So it's, instead of dividing, I take it times 1 over 1.10 for 1 period. Now, isn't that dividing? You know, you put the 133.10 over the top of the 1.1 and divide it in, you divide it. Okay, what will that give me, of course? 121. This is obvious, isn't it? Let this whole thing be obvious for you. It's going to work. What if we took that times 1 over 1 plus the interest rate? Well, yeah, it's going to be 1 over 1.10 again. And where will we be, guys? What's the future value? Future value at the end of 1 period. It's going to be 110. Of course it is. Right? We're just reversing this process, just going backwards. We're sucking the interest out. So here's when you have a future value and you want to get the present value. That's all you're doing. Take this times what? 1 over 1 plus the interest rate every single time will give me the present value, 1 over 1.10. Well, with these numbers, it's obvious, isn't it? $100. Okay? Now, does it matter if it's $2,486,000 received 20 years from now, and I'm going to discount it at 12.5% interest? Not in the least. You get the present value easy. And what did you say this was when you put this together? What is that? It's the future value in periods from now times what? 1 over 1 plus the interest rate, because you're dividing, raised to the number of periods equals the present value now. So in this case, I have 133.10 here, right? Times 1 over 1.10 raised to 3 periods equals the present value of 100, huh? Okay, what's that factor? Let's do that. What's that factor? What is 1 over 1.10 raised to the third? Somebody put it in their calculator. 1 over 1.10 raised to the third. What do you get? 0.7513.
Yeah.
Done it so many times I can remember it. Oh, I just recently did it in intermediate. 0.7513. What's worth 75 cents? $1 received 3 periods from now, discounted at 10% interest. How much interest do you earn on your 75-cent investment? If it's worth $1, then you get 75 cents now, you get $1 later. What interest rate do you earn? 10%. How much interest will it be? 25 cents. Makes it right. If you invest the 75 cents, you get $1 later. We're just sucking the interest out, you guys. Okay, take a look at the present value of the sum table. It's the one we use the most often. On A1, look at 10% column on table A1, on page A1. Table A1. 10% column. Go down to 3 periods. What's the factor? 0.7513. Okay, I want you to do one other thing. What is 1 over 1.3, was it 331?
What does that equal? Take 1 and divide it by 1.331. A dollar becomes $1.33 if you leave it for 3 years at 10%. What is it?
Same thing.
0.7513. Oh, what is one? Let's see. It's $1. $1 over 0.7513. There we go. What's that? 1 divided by 0.7513. $1 divided by 75 cents. It's 1.331. See what's going on with these tables? Just not a big deal, is it? They calculated it for you. Okay, what's a dollar discounted at, say, 15% for 20 periods worth right now? See, it ceases to be intuitive. Take a look at that. What's on that present value of sum table? 15%, 20 periods, what is it? Or you do it with your calculator, what is it? 6 cents, 6.1 cents. If you invest 6 cents at 15% interest for 20 years, what will it grow to? $1. Got it? Okay. Exponential growth. Okay? Yeah. You want to be rich someday? Okay. What if you did 12 or 13%? You know, this is only 20 years. How long have they been investing? 40? 4? Somebody take 1.12. Say your market earns 12% on average. I don't know exactly what it is. Something like that. Take 1.12 and raise it to the 40th one. What's that? 93.05. Every dollar I invested the first year I invested is now 93 bucks. Yes. I think that's enough. Crazy. Spent money on dumb things. Cars, eating out, having fun. I could have an awful lot of fun now. I would have to hang out with you guys at the end of Bahamas. Okay. By the way, how would you do it the other way around? If you want to have $1 40 periods from now, and you're going to earn 12%, how much do you need to invest now to have $1? Just do the reverse of it, right? What do? Put 1 over 1.12 raised to the 40th, right? Or it's just 1 over the 93, and okay, how much would I have to invest to have $1 now at that time? How much? About a penny. So every cent, yeah, it's a little more than a penny, right? Because a dollar becomes 93, right? So it's about 1.1 cent, right, to become $1 40 years from now. Start investing, you guys. What happens if you wait to invest until it's 2 years before you retire? The money I'm investing now. My wife and I invest a lot now. So what's going to happen to it? 6 years? Are you kidding me? It's only going to double once. The money I'm putting today. Most likely. Big deal. 90 times? So can you afford to invest? Probably not right now. Can you afford to invest the year that you start working to get out of college? Yes. Take 15% of what you make it, invest it, and live in a really crummy place and drive a crummy car. Or don't drive at all. There you go. Yeah. And don't keep doing that. Start enjoying life later. Right? After you have some done. Okay, anyway. Another concept. Annuity. We got one more piece. So here we go. What we've got, you guys, is just present value. You know everything about it now. Now, try working these problems. We've got a bunch of problems over the break, you guys. Just work with problem after problem after problem. Do them all at the end of the chapter. You'll be just fine. I'm going to expect you to know how to do this. Besides those, there might be an annuity payment. Okay? That's the other piece. There's 2 types of annuity payment. Well, first, what is an annuity payment? An annuity means it's what? Our actuary can tell us. What's an annuity? Well, that's true. That's true. But an annuity itself, a payment stream is an annuity. What is it? It's an annuity payment. Exactly the same amount every period. No period skipped, we say, which is silly because it's 0 is not the same amount. But anyway, I always say that. Okay, so exactly the same payment every single period, right?
And the interest rate isn't changing, because the risk level's not changing. So, you know, the interest rate doesn't change in the deal. We're going to value bonds in the next chapter. It's a lump sum payment at the end on the bond, paying off the bond payable, right? Or if you have the investment in the bond, you get the thing, right? And it's exactly the same interest every period. Always the same interest every period, no period skipped. And the interest rate stays the same. What do you think that is? That's an annuity. So an annuity is exactly the same amount of money every period, no period skipped, and you're assuming the interest rate stays the same. Got it? And all this is it's easier to calculate. Let's say I have exactly the same payment for 20 periods. What I could do is I could get either the present value or future value of those payments, right, of that one payment, right, for each of the 20, and then I could add the 20 together. I could calculate either the present value or the future value of each of 20 payments, because I'd have n is 20, right? I'd have whatever my interest rate is, 10, 12%, whatever, right? And I can be calculating either the future value or the present value of that annuity payment, right? But I've got 20 payments, so I'd have to do 20 multiplications and then add them all up. You know what we do instead? We have tables, or we have a calculator that does it for us, where they add up all the present value factors. Take a look at the annuity table, present value of an annuity, at the bottom of table A1. Okay? Let's use 8% because they're both on the first page. Notice what they have for one period at 8% up there on the present value of the sum. 93 cents, everybody see it? 0.9259? Look what's at 8% for one period on the annuity table. Exactly the same thing, because it's one period. There's only one payment. What if there's two? Well, look at what the second one is in the present value of the dollar table. 86 cents, everybody see that? 8573? Take the 93 cents and the 85 cents, 86 cents, and add the two together, and what do you get from the present value of the sum table? What's 93 and 86 added together? Add those two together, you get 1.7833. All they did was added up the tables for you. I'm not kidding. So if you go down to 20 periods on the present value of an annuity, it's worth $9.82. What's worth $9.82? What they did was they added together 20 factors. There aren't 20 in the table. But if you take all 20 and add them together, that's what the formula does. It's the sum of it, right? What it is $1 received at the end of 1 year, plus $1 at the end of 2 years, periods. $1 at the end of 3, 4, 5, 6, 7, 8, 9, all the way up to 20, right? So it's $20. $20 is worth what? Right now. $9.82. If I invested $9.82 right now, I could take out $1 at the end of every year for 20 years, right? If I'm earning 8% interest, and I will have exactly nothing left at the end, right? How much interest will I earn? Now you invest $9 and what? $9.82. And I get to take out 20. How much interest do you think you earn? How about $20 less $9.82? You earn $10.18 off of it. Off of that annuity, that stream. So what's an annuity, everybody? Exactly the same amount of money every period, right? No period skipped, and the discount rate doesn't change. And there's lots and lots of investments like this. Retirement plans like that. Okay? My wife and I figured out how much money we need to have invested when we retire. We have to make the same money when we retire that we make now, without taking any of the principal out, so we can leave it to our grandchildren. Not our kids, our grandkids. Right? Plan. Take a look at the future value of an annuity dollar. It's the same sort of idea, except at the first period is only $1. That's because it's an ordinary annuity. The payments are at the end of the period, right? So there's no interest on the first payment at the end of the period. That's how you earn the interest. But there is the interest of the present value. We'll talk about that next time. Try and do a bunch of these problems, you guys. Work as many problems as you can stomach at the end of this chapter. And also do the payroll stuff and the liabilities. We've done that stuff before. It's pretty easy. Payroll liabilities and accounts payable and salaries. We've done all that before. Do it again. And enjoy your break. But don't enjoy it much. Oh, I had your quiz. Oh, no. I posted your grades, right?
Yeah.
These are in alphabetical order.
I was okay with my grades this time. So you'll put on you want to write that thing? No. I'm going to stick with intermediates. So end of the
Got the
year.
knife shack, I forgot it last time.
Are we not doing,
Considering you guys
Then
were
you need to do a new
Yeah.
intermediate county.
Aren't you gonna get your quiz grades?
Yeah, ordinary.
are we gonna do, monthly or just?
Oh, sure, monthly, quarterly, and semi-annual, we'll do that, yeah. Just divide the interest rate and increase periods. Yeah, you'll like it, Jeff.
Yeah, so,
So much.
That's the other class. Were you in that group, or? That's the 11 a.m. class over there. Right. No, I can't believe it. Like that stuff. Hi. I left him in the intermediate here. Thanks for reminding me.
I was thinking, I thought you were gonna do it earlier, but then it's okay.
Keep that about it too.
I was looking at it, but then you did the lesson.
You should have said, hey, give it to me, I want it.